Hi DARKAN Primary School!
I'm Graham and I'm a structural biologist scientist from the Centenary Institute.
And my name's Mim, and I've heard that you guys have been studying space at school. So I've dressed up in this really cool spacesuit today. See, it says NASA. We're going to start out with our first experiment, which is called Earth in a Bottle. So we'll start out by putting some warm water in this bottle. Now that we have our water, we're going to add 3 teaspoons of sugar. I've got 3 packets here, but that's the same thing. So now we're going to add 1 ounce of yeast, which is about 28 grams, which makes 4 packets of these ones. Now we're going to cap it with this balloon. This one's going to take a little while, so I'll just let it sit for a bit.
Here you can see we've created some moon cycles with Oreos.
So the white on the Oreo represents the moon that you can see from Earth. So when there's a new moon, like this Oreo cookie here, it means that this moon is directly in line with the sun and the Earth. And then as the moon moves around, you get all these different kinds of moons.
This one is called a new moon because it's the first moon in the cycle.
And this one is called the full moon. You probably knew that one already.
This might look confusing because here we have a dark moon, but it's directly in line with the sun.
We can explain that using a torch and an orange. So as you can see here, if I shine this torch straight at you, it's like the sun. And then when I hold the orange in front of it, the orange is being the moon. And you can't see the light from the sun anymore, so it's all dark. But if I move the orange really slowly, that's like the moon moving around. And you can see the different light appear again. And what you can see here on the cookie is what the moon looks like from the Earth.
Here we've got some liquid nitrogen. And it's going to simulate what would happen if things were really, really cold. And this is one of the reasons why life doesn't exist as we know it on other planets.
So here we've got some plants that we just picked outside, and now we're going to put them in the liquid nitrogen and see what happens.
As you can see, this is really just a normal leaf. It's really bendy.
So now we're going to put this flower into the liquid nitrogen. As you can see, it's bubbling away there, and what's actually happening is that it's freezing.
So wait for it to stop boiling. So we know it's reached, I think it's minus 170 degrees.
Wow.
You want to crush this one?
If a plant tried to grow on Neptune, it would just freeze like this and wouldn't live. That's why we're so lucky to be near the sun.
Okay, so I've put a skewer through the middle of this orange to simulate the axis of the rotation of the Earth. And when I spin it like this, you can see that the Earth's now spinning around like it does once every single day.
Now this torch is going to be the sun, so when the sun shines on the Earth every day, it's daylight. And then as it turns around, the other side of the Earth goes to sleep and it's nighttime.
Because the Earth is on an angle and it's constantly rotating, the bottom half is closer to the sun, and the bottom half has their summer while the top half has their winter. But as the Earth spins around the sun and comes all the way around to be on the other side like this, you can now see the top half is closest to the sun, and as it spins around, the top half is now in summer and the bottom half is in winter, and that's why we have seasons. So when it comes all the way back around here again, the bottom half is now closest to the sun and now it's their summer.
So the axis of the Earth is actually what makes all the living things happen the way they do on our planet. So if our Earth axis was a little bit different, we might have totally different seasons, totally different humans, and totally different plants. We're just gonna check in on our bottle again. Look how big this balloon is getting. And the bottle's getting a little bit warm as well. So we'll talk about that later. So now we're going to talk about why the Earth is round, and we're going to use this experiment, which is called blobs in a bottle, to answer that question. It's a little bit different to what is happening in space, but it's a good way to replicate it here on Earth. So at the bottom here we've got water that we've put blue food colouring in, and then on the top of it is just oil that you use for cooking. So you might be able to see that the water and the oil is staying separate, and this is because water is much denser than oil. But when we put in one of these dissolving tablets, which is called aspirin, it will create a gas at the bottom, and then the gas will rise up to the top and bring the food colouring with it, and then escape out of the top of the bottle and float back down. So what we're looking out for here is the shape of the bubble that the gas is making.
So, the reason that the Earth is round is because you have all of this matter that's getting pulled together by gravitational forces, and because all of the forces on them are roughly equal, it sucks the Earth into a spherical shape.
See something similar happening in this bottle because the water doesn't want to mix with the oil. The oil is forcing the water to stay together, kind of like gravity, and making it a spherical shape.
So matter is made up of all different forms. It can come in as solid, liquid, and gas. And planets are made up of more solid parts, and other planets are made up of more gaseous parts. So here we have some dry ice, which is actually carbon dioxide, which is normally found in the air as a gas. And it's so cold that we've actually been able to turn it into a solid. And if you want to turn it back into a gas again, all you have to do is heat it up. One way of doing that is by just putting it in some water. As you can see, the dry ice is being warmed up by the water, it's being turned back straight into gas, and it's bubbling out the top.
So this is what some planets are like. Some of them are made up of solids, and some of them are made up of gas, and then some planets that are lucky, like Earth, have water on them. So you can see our balloon has gotten really big now. So everything we put in the bottle at the start, which was water, sugar, and yeast, means that this bottle is the perfect environment to grow, just like the Earth. So the yeast is growing in here thanks to the sugar and the water, and that's making the balloon get really bigger because it's emitting carbon dioxide. So this is really similar to what happens here on Earth. We have all the water and the heat and the nutrients we need to grow and live, and we breathe out carbon dioxide every day, which is what is in this balloon. So what you can see here is a tea bag. We've cut it open, taken all the tea out of it, and then it's made this little cylinder. So if we put it here and light the top on fire, just watch what happens. So as you can see, it turned into a little rocket. So the science that we used here today is similar to what NASA uses to make a rocket ship take off and also to float a hot air balloon.
So the reason that the tea bag went up into the air like a rocket was because when we lit it on fire, the air inside of the tea bag heated up really hot, and it caused the air molecules to move around really fast, and they bounced off each other really fast. And as they bounce off each other faster, they are able to move further and further apart. When things move further and further apart, they become what's called less dense. Less dense things typically weigh less than things that are more dense. So because it weighed less, it went up into the air like a bubble in water rises.
So now we're going to talk about how far we could jump if we were up on the moon. On the Earth, there's lots of gravity, but in the moon, there's a bit less, so we can jump a lot further. So Graham, why don't you do a big jump and then we'll measure it. Cool, now stay there. And you grab this end. So Graham jumped 1.5 meters. If he was going to do that jump on the moon, it would be 6 times that amount. So on the moon, Graham would have done a jump this long.
Go.
So last of all, we just want to say a really big thank you to your school for having a Suit Up for Science Day and raising funds and raising awareness for the work that we do here at the Centenary Institute. I hope you learned something from all our experiments.
Without the support of people like you, making donations for things to like the Suit Up for Science, we wouldn't be able to do the groundbreaking research that we do.
So thanks so much for your support. Bye. Everyone!